Hello students, welcome to a new session of maths. We are doing chapter 5 understanding elementary shapes. Today's session you are going to learn about perpendicular lines. When two lines intersect and the angle between them is a right angle, then the lines are said to be perpendicular lines. So if two lines intersect each other at right angles, intersect each other means meet each other. If two lines meet each other at right angles, then the lines are said to be perpendicular lines. Here I have taken two lines, line AB and line CD. This line AB intersect line CD at a right angle. Right angle means angle of 90 degree. So we can say line AB is perpendicular to line CD. See, symbolically we can write it as line AB is perpendicular to. This how to read? Is perpendicular to. Line AB is perpendicular to line CD. And if line AB is perpendicular to line CD, we can also say that line CD is perpendicular to line AB. That means they are perpendicular to each other. And in English alphabet, many capital letters like E, F, H, L and T show the property of perpendicularity. See, here let AB be a line segment, mark its midpoint as M. A line segment is taken, line segment AB, and it will be marking its midpoint M. Midpoint means that is the point at the middle of the line segment. That means the distance between the point A and M is equal to the distance between the point A, B and M, as M is the midpoint of line segment AB. Now let line MN be a line perpendicular to line segment AB through M. Now we are taking the line NM which is perpendicular to line segment AB and passes through the point M. See, this line NM is perpendicular to line segment AB. Here, MN divides AB into two equal parts. Line NM divides the line segment AB into two equal parts. That means the distance of AM is equal to the distance between BM, the point B and M. So we can say that line MN is the bisector of AB, line segment AB. Line NM is the bisector. Bisector means the line that divides into two equal parts. NM divides line segment AB into two equal parts. And NM is also the perpendicular line. So we can say that MN is the perpendicular bisector of line segment AB, because here NM divides AB at a right angle, so it is a perpendicular line, and it divides into two equal parts. That means it is bisector also. So we can say that MN is the perpendicular bisector. It is perpendicular and also it divides into two equal parts. So we can say MN is the perpendicular bisector of line segment AB. Now we will discuss the questions given in 5.5. First question, which of the following are models for perpendicular lines? In that the first one is the adjacent edges of a tabletop. Children, you know that the tabletop is rectangular in shape, right? And here four sides are there. And there are four pairs of adjacent sides. Sides and edges are same only, edges or sides. Four pairs of adjacent edges are there. What are adjacent edges? Two edges having a common vertex is called adjacent edges. Here we will consider these two edges. See, this vertical side and this horizontal side. They form one pair of adjacent edges. Here, see, this horizontal and this vertical part will form the second pair of adjacent edges. Again, this vertical part and this top side will form the third pair of adjacent sides. Again, these sides, this side, top side, and this vertical side will form the fourth pair of adjacent edges. That means a tabletop has 4 pairs of adjacent edges. Now see, this vertical line is intersecting this horizontal line at an angle of 90 degree. So it's an example of perpendicular lines. The adjacent edges of a tabletop are the models or the examples for perpendicular lines. Now the next question is the line of the railway track. See, these are the lines of the railway track. And you know, they are parallel lines. They never meet each other. They never cross each other. The railway track lines, they never meet each other. So they are not the examples of perpendicular lines. Perpendicular lines are those lines which are meeting each other at right angles. And the lines of the railway track, they never meet each other. So they are not the examples of perpendicular lines. Instead, they are parallel lines. What are parallel lines? The two lines that never meet each other. And the distance between the two lines is same everywhere are called parallel lines. So the lines of railway track are parallel lines and they are not the examples for perpendicular lines. The next question, the line segment forming the letter L. See, here two lines are there, one vertical line and one horizontal line. Both the lines are meeting each other at a right angle. So, it's an example of perpendicular lines. Next one, the letter V. Here letter V also two line segments are there. They are meeting each other, but the angle formed between them is not a 90-degree angle. It is not a right angle. It's only an acute angle. So, it is not the example for perpendicular lines. In perpendicular lines, two lines should meet each other at a right angles. So it is not the example for perpendicular lines. Now the next question. Let a line segment PQ be the perpendicular to the line segment XY. Let line segment PQ and XY intersect at the point A. What is the measure of angle PAY? We have already learned that when two line or line segment meet each other, they are said to be perpendicular lines only if they meet each other at a right angles. Here it is given they are perpendicular. It has the meaning perpendicular line means the angle between them will be a right angle. And you know the right angle is 90 degree. See, here I have drawn the line because line segment is a part of the line. So we will take only the line segment PQ and the line segment XY. And here line segment PQ is perpendicular to line segment XY and they meet each other at the point A. This is the point of intersection where both the line segments are meeting. Now we have to find out the measure of angle PAY. See, PAY is starting from here. PAY, this is the angle. What type of angle it is? It is a right angle. This symbol shows it is a right angle. Okay, children, right angle measure, you know, 90 degree. Angle PAY is 90 degree. Okay, next question. There are two set square in your box. What are the measures of the angles that are formed at their corners? Do they have any angle measure that is common? You know set square. Set square is one of the a pair of instruments in your geometry box. In your geometry box, one scale will be there, one protractor is there, and two other instruments are there. They are called set squares. They are in this shape. See, one will be of this shape, and the other one, second one will be of this shape. These are called set squares, right? And if we measure, we can see that one will be of the measure 30 degree. This angle will be 30 degree, and here 60 degree, and this will be 90 degree. So in one of the set square, the measures of the angles are 30 degree, 60 degree and 90 degree. And the second set square, the measures are 45 degree and 45 degree. Two angles are 45 degree each and the third angle is 90 degree. And you know, the set squares are triangular in shape. The sum of the measures of all the three angles of the triangle is 180 degree. That is, you should remember 180 degree. Sum of the measures of three angles of the triangle is 180 degree. Here you can see 30 plus 60, 90, 90 plus 90, 180. Here also two angles are of the same measure, 45 degree. Each 45 plus 45, 90, 90 The third angle here, I have not given the measure, only to make you understand this symbol shows right angle. And right angle means 90-degree angle. So 45 plus 45 plus 90, that is 180. So the measure of the angles of one set square is 30, 60, 90. That is the set square. And that of the other one is 45, 45 and 90 degree. 45 degree, 45 degree and 90 degree. And we can see in both the set square, one angle have the same measure, that is 90 degree. 90 degree is the common measure. Here 90 degree and here is the 90 degree angle. So both set squares have one common measure, that is 90 degree. Okay, now we will consider the fourth question. Study the diagram. This diagram given. The line L is perpendicular to the line M. Line L is perpendicular to line M. And we have to see whether CE is equal to EG. CE, what is the measure of CE? Starting from C and E. The distance between C and E is 2 units, right? And here the points are marked at the same measure, same distance. The point distance in between is 1 unit in each case. So the distance between C and E is 2 unit, or we can say the measure of CE is 2 unit. Same way, the measure of EG, E to G, from here F and G up to G we have to find out. EG also 2 unit. So the distance between CE and EG are same, that is 2 unit. That means we can say CE is equal to EG as the distance is same in both the cases. Second question, does line PE bisect CG? So this is line PE, that is line M. Line M is given by another name PE. And we have to see whether it is bisecting CG. Bisecting CG means divide CG into two equal parts. See, here when the line PE bisect CG, CG means from here to here. What is the distance? 1, 2, 3, 4. 4 units are the distance of measure of CG. And here, if it is bisecting, it is dividing it into two equal parts, that is CE and EG. Right? CE, E and EG. And what is the measure of CE? We have already got CE 2 unit and also EG 2 unit. The distance of CE and EG same only. The measure of CE and EG same. So we can say that line PE bisect CG. The total measure of CG is 4 centimeter or 4 unit, and it divides into two equal parts. PE divides it into two equal parts, that is CE and EG. So we can say that line PE is the perpendicular bisector of CG. Now next question, identify any two line segment for which PE is the perpendicular bisector. We have already seen now the previous question. It is a perpendicular bisector of CG, line segment CG. So I have not taken that example. Other two examples I have taken. So I have taken DE and EF. See, DE, what is the distance of DE? D to E, 1 centimeter. Same way EF, EF also 1 centimeter. DE and EF are 1 centimeter each. So we can say that line P is the bisector of, perpendicular bisector of DF, D to F. Right? Second example I have taken BH. See, from B to H. And this BH is bisected by line PE. And it is dividing into two parts, that is BE, BE and EH. What is the measure of BE? B is equal to 3 unit. Same way EH also measures 3 unit. That means the measure of BE is equal to the measure of EH. From that we can say that line PE is the perpendicular bisector of line segment BH. Okay. Now the next question. Are this true? First one. AC is greater than FG. We have to locate AC. Where is AC? The measure of AC is 2 units. See, A and C. It is 2 unit. And FG, we will see FG measures only 1 unit, right? So the measure of AC 2 unit and the measure of FG is 1 unit. And you know 2 is greater than 1. Therefore, AC is greater than FG. That is true. Second, CD is equal to GH. CD measures 1 unit and GH also measures 1 unit. GH, distance between G and H, that is 1 unit. CD and GH both have the same measure of 1 unit. So CD is equal to GH, that is also true. And the third question is, BC is smaller than EH. What's the measure of BC? BC measures 1 unit and the EH measures E to H. 1, 2, 3, 3 unit. So BC 1 unit and EH 3 unit. 1 is smaller than 3. So we can say that BC is smaller than EH. That is also true. That means all the 3 given statements are true. Okay, children. The next part I will explain in the next video.